Example 6, we're going to come in and take a look at a polynomial function. We're still following that 5-step process. F of x is equal to 9x minus x to the third power. We're going to notice that this is in standard form or non-factored form is really what we're after here. The first thing I'm going to do is actually put it in standard form by putting it in descending order. So negative x cubed plus 9x. And we're going to need to factor it. In order to pull those zeros out, we have to have it in that factored form. So to factor it, I'm always going to look for the GCF first. And the greatest common factor here is an x. And let's go ahead and pull out a negative x. That'll leave me with x squared minus 9, which I can then factor into x plus 3 and x minus 3. That's the difference in squares. So factor is fairly straightforward. So that was nice. So it wasn't too bad to factor it. You can do this. Okay, well, what happens then, we'll start our analysis. The power function was a negative x to the third. That was this negative now impacting us for the first time. That tells me normally the odd ones start below and end above, but because the negative is going to reflect it across the x-axis, this is going to start above and end below. In terms of x-intercepts, sorry, I don't know why I'm frog all of a sudden. Multiplices, bounce and cross. Okay, well, looks like we've got 3 of them. So the first one's going to be at 0, 0. Its multiplicity is a 1, which is telling us it's going to cross. The next one is going to be at a negative 3. And again, what I'm doing is saying each of these factors equal to 0 and solving them in my head. So negative 3, 0. Its multiplicity is 1, which tells us it's going to cross. And then finally, we have positive 3, 0. Its multiplicity is a 1. So again, it's going to cross. The y-intercept is easier this time. Again, what I do is I look at my x-intercepts. If I see the origin, I already know that that's the y-intercept. I don't even have to go looking for it because I've already found it. The other thing we need is the turning points. So the turning points is the degree. The degree was 3. And minus 1 is going to give us 2. And there it is. That's all we need to graph it. So we have positive 3. Sorry. Yeah, positive 3, negative 3. So when you first start this, it's like all I have is 3 points, but that's all we need. We know what the end behavior is. We know this one's going to start above. It's going to cross at each of those. So it's probably a nice, smooth, probably even got some symmetry to it, to the origin. We could check that if we wanted to. Notice that it's going to fold over and then fold up. It's got some symmetry to the origin. So it's an odd function, right? So it's kind of nice. There it is. Ta-da. Let's factor another one. See how that goes. So this is example 7. Example 7 says f of x is equal to 2x to the 4th plus 12x cubed minus 8x squared minus 48x. So when I look at that, don't freak out. You know what to do. Always look for that greatest common factor first. So in this case, I can pull out an x, and I can also pull out a 2. So we're going to pull out a 2x to start the factoring process. That'll leave us with x cubed plus 6x squared minus 8x minus 24. Notice that I have 4 terms on the inside. You'll notice this thing is in standard form and it's descending order, which is great. But we have 4 terms on the inside. And if you remember from factoring clear back in section 1.4, when we had 4 terms and we were asked to factor, we used grouping. So again, grouping, you might want to go back and review that. So grouping, and that's because it's 4 terms. Okay, so I'm going to keep the 2x out in front. I'm going to go to a bracket just to help keep track of things. The first 2 terms, we can pull out an x squared. That's going to leave me with x plus 6. I bring down the sign. That's this negative sign coming down. For the last 2 terms, we're going to pull out a negative 8. To pull out a negative 8, I'll be left with 6. Negative 24 divided by negative 8 is a positive 6. So sure enough, those 2 sets of parentheses are the same, which is what we need. So we're going to pull the x plus 6 out in front. Left over is this x squared and this minus 8. Yay! That's not right. Boy, it's a good thing I'm caught, and I'm glad you guys are all yelling at me. And how did I know? Because I got down to that x squared minus 8 and it didn't factor. So, sorry, when I pull the 8 and divide out the 2, I'm going to get a 4. That's going to make that a 4. And yes, indeed, when I pull that 4 out, 4 times 6 is the 24. Okay, I'm with it now. We caught our mistake. We have x plus 2 and x minus 2. So at this point, it will factor. So yay, and there it is. So now what? Well, now what we're going to do is come in and do our analysis. We're running out of room. So I'm going to do the analysis over there. You erase this and graphing it. We know that the power function, way back at the beginning, in its standard form, was x to the 4th. Because that is even as a power function, we know it's going to start above and end above. In terms of the x-intercepts, we have quite a few of them. See if we can squeeze them in. They're multiplicities, and they're bouncing and crossing. So in, well, not in numerical order, but in order, we're going to pick up 0, 0. We're going to pick up negative 6, 0. We're going to pick up negative 2, 0. And then finally, we're going to pick up a positive 2, 0. And that's all of these factors giving us a 0. Their multiplicities, they're all 1. Every single one only appears as a factor 1 time. And in terms of crossing and bouncing, we now know it's going to cross it, all of them. So cross, 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 and cross. Okay, what about a y-intercept? Well, again, take a look at those x-intercepts. One of the x-intercepts is the origin, so your y-intercept had better be at the origin also. And finally, we need turning points. That comes from the overall degree, which was 4 minus 1, which is 3. And this one's actually going to have those 3 turning points. So, okay, now we can graph it. So the only thing that really slowed us down was the factoring, and that didn't slow us down too much. So we have, let's see, 0, 0. Negative 2, negative 6, and a positive 2. The y-intercept is at the origin. So those are all our points. We know that it's going to start above, it's going to end above, and it's going to cross at every single one of them. So I'm going to come in and just nicely make a smooth and continuous graph going through all those points. Again, we do not know where these maximums and minimums are. Calculus is what's going to give us those tools, and we're just not there yet. So beautiful picture. Good.